Hi class, we're going to start chapter 7 now. This is lesson 7-1 titled How to Apply the Pythagorean Theorem. So this was a famous theorem that was found by a man named Pythagoras, and here's what it says. It says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So if we recall, hypotenuse is the side of a right triangle that's opposite the right angle, and the two sides that are adjacent to the right angle are called the legs. And so we wrote this out as taking the square of both of the legs and adding them together, and that is going to equal the hypotenuse when it is being squared itself. So let's just kind of keep that in mind, because this is what we're going to be using this whole section. Okay, so our first example is just asking us to find the leg that is unknown. So what I want us to do is to first start by writing a squared plus b squared is equal to c squared. We're going to write this at the beginning of all of our problems, and then we're just going to fill in what we know. I know one of the legs is 6, so I'm going to write 6 squared. One of the legs is unknown, so that's going to be your x squared, and the hypotenuse is known, it's 10, so I'm going to fill that in. So 6 squared is 36, x squared is going to remain, and 10 squared is 100. Okay, then I'm going to subtract 36 on both sides, and I have x squared is equal to 64. Now that's not my final answer. To get x by itself, you're going to take the square root of both sides, and then we're going to find that x is equal to 8. We know it's positive or negative, but we're only going to have positive distances for lengths. So x is equal to 8. I'm done. For my other example, this time I want us to find the hypotenuse. So it's not too bad. We're going to again write down the formula a squared plus b squared is equal to c squared, and we're going to fill in what we know. A is one of the legs, that would be 4. Another one of the legs, b, is 6, so we're going to write 4 squared plus 6 squared is equal to x squared, because I don't know what that is yet. 4 squared is 16, 6 squared is 36, and that's all equal to x squared. When you add those together, you get 52. And then we're going to take the square root of both sides. Now, I don't know what 52 is when I take the square root. So what we need to do is we need to just write it in the simplest form. And so we're going to think, well, what two numbers, when I multiply them, do I get 52? And I can say 4 times 13. That's going to give me my x. And the square root of 4 is 2, so in the end I'm going to say the answer is 2 square root of 13. That is going to be the length of my hypotenuse. And now I'm done. Okay, let's move on. I want to show you how easy it is to prove the Pythagorean theorem. You may have seen a video on this before, but I'm just going to show you once again how easy it is to prove that this is true and not just accept it. Okay, so we're going to start with a diagram. Let me show you the diagram first. The diagram has a very large square that's green, and then inside of it there is a smaller square. And the way that we're going to prove the Pythagorean theorem is taking the area of this large square and then just setting that equal to all of the smaller parts that make up this large square. So we would say that the area of the large square is equal to the area of these 4 little triangles plus the area of this red smaller square. Okay, so let's just go ahead and do this. So let's see here. The area of the large square is going to be length times width, right? And since it's a square, both sides are the same all the way around. So a plus b is going to give me one of the sides. And I'm going to write a plus b, and I'm going to square that, because it would be side squared. The area of 4 of the triangles, so I'm going to have 4 of them, and we know the area is 1/2 base times height. So if I'm looking, it looks like let's just take this one for example, that the base is A and the height is B. So A, B. Plus the area of the smaller square. And this red square, each side is C, so it's going to be C squared. C times C is C squared. So now let's just go ahead and break this down. We're going to have to use FOIL here to figure out what that is. 4 times 1/2 is going to leave me with 2AB, and I can't simplify the C squared anymore. So let's go ahead and do FOIL. A times A is A squared. Let's do A times B plus another A times B plus B squared. That's all equal to 2AB plus C squared. Well, I have an AB and another AB, so that leaves me with 2AB and then simply if I subtract this 2AB on either side, it's going to cancel out on both sides, and you're going to be left with A squared plus B squared is equal to C squared. And that's our Pythagorean theorem. So I'm going to leave you with one last example now. In this example, you're just asked to find the area of the triangle. So again, we remember that the area is 1/2 base times height. Now, in this example, I know that the base is 20, but I don't know the height. Remember, the height has to come perpendicular to the base. So how can I find that? Well, why don't we just maybe look at one of these smaller triangles right here. And then maybe I can find out what that missing side is of this smaller triangle. So if I have this triangle and I use the Pythagorean theorem, A squared plus B squared is equal to C squared. What would one of the sides be, one of the legs? Well, if this entire part is 20, then half of it is going to be 10. So 10 squared plus, I don't know this other leg, that's going to be B squared, but I do know the hypotenuse is 26 squared. Okay, so let's just work this out. 10 squared is 100. B squared is left alone, and 26 squared is actually 676. So then we're going to subtract 100 on both sides, and we're going to be left with B squared is equal to 576. And then when I take the square root of both sides, I find that that missing leg is the number 24. So now I know that the height of this triangle is 24. So let's find the area. Area equals 1/2 base times height. So it's 1/2, the base is 20, and the height is 24. The 1/2 and the 20 can cross cancel, and I have 10 times 24, which equals 24, and it's going to be 240, meters squared is going to be my area. And I'm done. So on your own, I'd like you to do a problem just like this. And I want you to try it out before you come back to class. Find the area of this triangle, and it has the base is 30, and it has 2 of the sides, which are both 18 feet, but we don't know what the height is. So go through the same process and find it out, and I'll see you when you come back to class.